Yes.
Okay. Okay. Good morning, everyone. I'm happy to be here to give you a presentation about some introduction to the continuous fiber reinforced thermoplastic composite. This is some work before I joined Kingfa India. This is really some new material. So I think after my report, everyone can understand, and in the future, if you have some requirement, you can find some application to use our material. So my presentation have three report. The first one, I would like to give some rough introduction for the lightweight solution. The second is to introduce this continuous glass fiber reinforced thermoplastic, which we already have some product in China. The third part is some application. Then we will understand how to use this CFRTP. Okay, first I would like to introduce two electric car. First one is BMW i3. The second one is Tesla Model 3. So these two cars and the design body, we will have some understanding about the structure, about which material they're using. Okay, on this slide, on the left is the white body of Model 3. They use steel combined with aluminum material. And for this steel, they have a three kind of label. The first one is normal steel. The second one is the high strength steel. And the last one is ultra high strength steel, which will have a very high strength and modulus. So in this part, they can decrease the thickness. So by this kind of material, they can decrease the weight of white body. And the weight of white body for Model 3 is around 350 kilogram. So this is very is normal. But in Model S, they will use the white body is only made by aluminum, but the price is much higher than this, and the welding is a little difficult. Okay, so this is Model 3. By using some ultra high strength steel and aluminum, they can get some weight reduction. Okay, then we come to the BMW i3. This car is used. Most of the white body is carbon fiber reinforced composite. Okay, the weight of the total weight is only 138 kilogram, so it's at least 200 kilogram lighter than normal white body. Okay, and the whole weight of BMW i3 is only 1.25 meter ton, and they use the adhesive to combine the different part to make the complete the one structure of white body. Okay, so this is the first car they use the carbon fiber composite. So by this kind of meaning, this is the useful for the automotive. And just now we show the four kind of material used for our automotive, which can have different application. First one is the high strength steel and the aluminum magnesium alloy. These two part, this material is mainly used for the structure part, like the white body. So the modulus is very high. It's 200 GPa or 70, but the weight is much higher. Like the steel is 7.8. So this is if we change to another material, we can make some to have some lightweight. And then we come to the compounding plastic. The compounding plastic is mainly used for exterior or interior of the automotive. And the density is very low, but the property, especially the modulus, is much less than the steel. Okay, so most of this part is just used for some part. They don't have a much load. They just for some bumper IP and the door trim like this. So they can make a very complex complex structure by injection molding. So that's why the plastic is used a lot in also in automotive. And the last one is advanced composite. So this is a very new material. Just as I give an introduction to I3, they use the carbon fiber reinforced epoxy. So this material have a very have a less density, and the modulus is close to the aluminum alloy. So if we use this composite, we can have a lighter and to get stronger together. So this is what I'm going to introduce for this kind of advanced composite. Okay, so if we want to get a good property, so we need to use continuous glass fiber reinforced thermoplastic. This is like the reinforced concrete for the building construction. Okay, so this is if we building a wall, a roof, we need to use together with the rebar and the concrete. So by use these two material, they can get some stronger and more stable construction. Okay, so for our thermoplastic composite is the same. We need to use the fiber. We need to use the continuous fiber to maintain the structure, and we use the resin as one as the function is like the adhesive to combine the fibers together. Then we can get a good composite which have a higher strength and a low density. So if we check why the fiber should be continuous, we can have a look at this kind of, we can have a look at this photo. So this is the fiber length. If we use the only the resin, there's no any glass fiber. So the property, such like the strength and the modulus, is very lower, but it can injection to different product. If we add some chopped glass fiber, the fiber length in the final product is less than 1 millimeter. So the property will increase a little. The strength and the modulus will increase. If we use some LFT, the fiber length is about 5 millimeter. So the property will increase again, especially for the impact strength is much higher than the chopped glass fiber. So this is for injection molding. The fiber length is only 5%, 5 millimeter, less than 5 millimeter. Okay, if we use the endless fiber, like we use the glass fiber fabric, the woven fabric. Also, we can use some UD tape. The strength of this kind of material is very close to the aluminum and the steel, even to the high strength steel. So this kind of material have a very good strength, but due to the structure, they cannot to do the injection molding. What we can do is use to compression molding to make a very simple product. Okay, so this is why the fiber lengths have so many the fiber lengths can define the final product property, because in the continuous fiber, if the part break, it should the fiber, the glass fiber should also break. So that's by this way the strength is increased a lot. And the thermoplastic composite is the history is begin at 1990. So in Europe, they want to use this kind of material in the plan. So they make carbon fiber reinforced PET, also some with PPS and the PEK. So by this kind of material, they can have a good strength, high modulus, and also the flame retardant is very good. So this part is already used for Airbus. The composite, thermoplastic composite is about more than 50% in the plane. Okay, but the price is very high because they use the carbon fiber. They use the high performance plastic like PEK, PEKK. So it's not in our civil application, we cannot bear it so much cost. So that's why we need to change the carbon fiber to glass fiber. And also we should change the design from high performance plastic to commodity plastic, such like a polypropylene, polyethylene. So then we can control the cost, but we still have a good property. So in this slide, we compare different three kind of properties. First one is the in BMW i3, they use the carbon fiber reinforced epoxy. The density is only 1.45, and the tensile strength is 1300, is much higher than the steel and aluminum. And the flexure is close to the aluminum. So that's why the carbon fiber reinforced epoxy can decrease the weight reduction, and the strength is much higher than the steel. Okay, but the price is very high. It's at least 10,000 rupees per kg. So for some application, we cannot use this material. So we can choose to use glass fiber reinforced polypropylene. The property is a little lower than the carbon fiber reinforced epoxy, is 800. And the density is increased a little, it's 1.8. So if we compare this material with aluminum, it also have some advantages with the strength and the low density. The only disadvantage for this material is the flexure modulus is only 25 GPa. So this is much less than the aluminum, but we can make some structure design, then we can to make the part can meet the requirement. Okay, so now it's come to our continuous glass fiber reinforced thermoplastic. In our material, we have some different kind of design, such like polypropylene, polyethylene, polyamide, ABS. We can use a different design to make this product. And we can find the fiber weight ratio is much higher than compounding. The minimum glass fiber is at least 50%. So some fiber content we can up to 70%. So this is this is because of the some processing requirement and the property requirement. With high content of glass fiber, the property will increase a lot, and also the processing is very easier. And our continuous glass fiber reinforced thermoplastic, we have a different kind of shape. The first one is the UD tape. It's just like a one film. We can find this in the right one. We can find this layer, this black layer. It's just like this one film. And in the film, there are many fibers in the same direction. This is we take it as 0 degree. So all the fiber is in the same direction. So in this direction, the strength is very strong, but in other direction, the cross direction, the property is much less. So this is the property for the structure for the UD tape. So that's why we use more layers with different glass fiber direction, like 0 degree, 45 degree, 90 degree. Then we use 4 layers, 5 layers, or even more layers to lamination together. Then we can get some sheet or very thick panels. So by use this lamination design, we can make the a panel or sheet. They have a uniform property along with different direction. So this is our 3 different shape of composite product. The first one is UD tape. The thickness is from 0.15 to 0.4 millimeter. This kind of tape is mainly used for RTP pipe. This is in the middle layer for reinforcement. Also, we can use for co-extrusion to put this in the profile or some wood plastic panel. So this is the application for the UD tape. Second is the our laminated sheet, and we can use compression, injection, and the injection forming to make different kind of panels in automotive and in some trailer. The last one is some panels, the thickness is about 2 millimeter. So we can use them directly. They can assemble with some bolt and nuts. This is the production process for the CFRTP. We have at least have 3 steps. One step we should to make this UD tape. We use our glass fiber to make the UD tape rolls. So this is to make the our semi-finished product. Then we use this UD tape. We use different layer to laminate to lamination, and then we get the final product. In this step, we need to use some lamination machine. This is continuous production. So we sell this product to our customer. They get this product, they can use directly. They can also to use some different processing like compression, injection to make the final product. So I will explain how to use this material later. First one, I would like to introduce how to make the UD tape. This is which we called Kingfa. Here is some racks. We put all the glass fiber rolls in this place, and we introduce this fiber to the fiber spreading. And then here is a mold. The PP resin is melted and come into the mold and contact with the glass fiber. After the impregnation, the UD tape is coming from this mold, and then we will cooling and cutting. Then we finally get this UD tape rolls. So this is the first step to make the continuous fiber reinforced thermoplastic. So during this production, all the glass fiber is continuous. So there's no breakage along the machine direction. Here is some property of our UD tape. We have a polyethylene ABS and polypropylene. We can find the 0 degree along the glass fiber direction. The tensile strength is very high. It's about 730, 580, and 750 with different glass fiber. But in the 90 degree, because there's no any fiber reinforcement, so the property is similar, is close to the resin property. So for this kind of UD tape, we can use for co-extrusion and the widening process. Here is some application for the UD tape. In this photo, this is one PVC panel. This is wood plastic. And in the middle layer, we have a 2 layer of UD tape. This is ABS with 50% glass fiber. After we add these 2 layers in this profile, the deflection under this load is decreased a lot. This is a video, some person standing on this to check whether it will break or not. So its performance is very good. Another one is RTP pipe. This is HDPE pipe. In the middle layer, they have some, the white one is the middle layer. We use the widening process to reinforce this HDPE file, so the property will increase a lot. Then we come to the Kingfa. So this this material, we have 4 layers. The thickness is only 0.6, and because we have a 0 degree, 90 degree, 90 degree, and 0 degree, so the 0 degree and the 90 degree, the property is the same. There's no big difference. That means if we use in our final product, the property is much more uniform. So for this material, the application is for the door carrier plate. This part is already in the Ford Focus in China and in Europe. So the processing is very new. They use the compression and the injection in the same time. And here is some production of our Kingfa in our plant. Here is the 0 degree, and the robot placed the 90 degree UD tape in the 0 degree. So by this, then we can get a 2 layer 90 degree lamination. And the second step, we use these 2 rows combine to lamination again. Then we get 4 layers. And this is the final product. The thickness is 0.6 millimeter. And after we get this product, we use die cutting to cut it to the shape. So this one is the front door. The second one is the rear door. And we sell this product to the cutted pieces to our customer. And they will use this compression and injection method to make the final product. So this is so the heated sheet is fixed on the mold, and then the mold allows to form some shape, and then injection. So this is the final part after the cutting. This is final part come to here. Okay, by this step, they can compression and injection in the same mode, then they can get a hybrid structure. So this is how to make this door career. And the thickness for this product is only 0.6 millimeter, and the weight reduction is 30% compared to LFTPP. And the impact property is also is better than LFTPP. So with this kind of method for compression and injection together, we can make some other part like the rear beam. So we also try use 3-point millimeter King Eco pen with some non-LFTPP to make this part. And here I would like to introduce another application of Kingfa, the sheet and the panel, to the trailers. So this trailers is many in USA and in China, and there are many used for transportation for some vegetable, some meat and medicine, which needed to keep at a low temperature. So the ceiling, the side wall, and the door, even the sub-pan, they have some sheet. They will use this kind of material. So this is we can design different structure beside our UD tape 090 degree. We also add some PP film. This is one with good surface which will contact our food. And in the middle, we have some aluminum foil, which can prevent the moisture and the gas into the trailer to prevent the temperature, to keep us a low temperature. Also, we have some non-woven fabric, which will bonding with the foaming. So this is the assemble of the trailer. So this is structure. The outer layer is the steel, and the inner and the inner layer is our thermoplastic composite, and in the middle is the PU foam. So this is like sandwich panel. So this panel have very good impact property. Even with this hammer, they cannot have any breakage. So the impact property is very good. And the third part is the King pen. This is some panel we can use directly. Here we have some application for the rear seat frame. And if we use some compounding during the luggage impact test, it will broken quickly. But if we use the this panel, they can pass this impact test. We also use this panel to replace the steel plate in the to protect the battery, so we can get a weight reduction, and also this is no rust compared to the steel. And the last, I would like to introduce the guardrail rail application for the highway. So this we use 6mm King pen, and we do some test. Here is one car with 6 km/h to impact. This is just like a simulation of accident happened. The car can come out. If the cars go cross this guardrail, then it means it fail. So if we use this King pen, we can decrease the opportunity of injury if the accident happened. So this is the advantage of our continuous glass fiber reinforced polypropylene. Okay, so this is my introduction. Thanks.
Thank you, Mr. York. It was an excellent presentation and a lot of details. What we'll do is we'll have 2-3 minutes for some questions. I think I have received on the chat mode 4 or 5 questions. Mr. Balaji, is that fine? Or we are cutting short of time? Can we take some questions now, or we should go to the next? What is your?
Normally, we take it at the end together.
Okay.
Mr. Nanda would take it at. We can go ahead the second presentation.
No
Question
problem.
and answers will come at the end.
Okay, so that's fine. Okay, so let's go to the next presenter. Next presenter is Mr. Srinivas, who is from Sundaram Polymers. He's a master graduate in polymer science from University of Mysore. He has about 20 plus years of experience in compounded engineering thermoplastics. Very impressive. He's a Six Sigma black belt from AU TVS Center for Quality Management, and his area of expertise includes